All right, yeah, thanks, Mark. Okay, so once again, we've got Phil D'Agostino and Kaylin Zhang here from Qubole. So Phil is a sales director at Qubole with a background, I guess, leading teams in enterprise software, cloud, and cloud computing. And Kaylin is a solutions architect with a great deal of experience in enterprise data management and related fields. Previously has worked for Splice Machine, March 1st, Informix, and Tandem Computers, among others. Qubole is a really interesting company. I think I've been working in the enterprise software fields for over 5 years, and I mean, two things that I think we've seen within that that field is the rise of Hadoop and related technologies as a platform, and then the rise of cloud computing. And Qubole, I think, really sits at the intersection of both of those. So I'm certainly very interested in the talk. So let's give a warm welcome to Phil and Kaylin, and thank you very much. We'll pass it over to Phil, who will begin, and then Kaylin's going to give a lengthier technical talk after Phil.
Thank you. All mic'd up and clipped up here. So good evening, everybody. Thanks for the opportunity. I'm going to introduce you to Qubole. I'm a sales director, but I'm not going to try and sell you. I'm just going to, awareness about, what we're all about, what we offer. Can you hear me now?
I can hear you, but over there, I don't know.
You're a little quiet.
You probably need to move that into
Point the
higher
mic.
Is this better?
Yeah.
Oh, yeah.
All right. All right, so housekeeping, I'm going to take care of that and then get into the introduction to Qubole. So as far as the housekeeping, we're going to send around this sign-in sheet. Just put your contact information, and you'll be lightly marketed to until you opt out. And good news, bad news on that. So everybody who does put their information in, we have a $50 Amazon gift card. And with all the statisticians in the room, I'm sure we'll come up with a very random way of giving it out. But again, you have to sign in. You guys decide. And one of the things I'm going to mention, I'll steal that thunder now. So our two co-founders actually built the big data platform that's in use at Facebook. And one of the things they did is thanks. One of the things they did, they created the Apache Hive project, which is in use by most folks that use Hadoop. And one of the things that we have on our website is the Hive function cheat sheet. And every day we get literally hundreds of people coming to our website to download this cheat sheet. So we made a bunch of copies. If anyone wants to use it, if they use Hive and wants to grab one of these, it's here, and obviously it's on our website as well. We've got some swag. We have some pens with Qubole. We've got these very cheap and flimsy mouse pads, stickers so you can decorate your laptop, and a description of our notebook, which is Zeppelin-based. And then one of the slides I'm going to take you through is the way you drive your queries and which engines we support within Qubole. And again, that's up here. So remember to sign in to get eligibility for the $50 gift card. So with a show of hands, how many people have actually been involved in a big data project in their career? All right, so more than half. So what was the average length of time? Was it a week? Was it a year from the time you said, we're going to do this, and the time we were able to actually start querying? And anybody want to throw out, a year, year and a half, a month? Any comments? 6 months?
9 months.
9 months? Okay, so the industry average, people say it's anywhere from 6 to 18 months. So one of the things about Qubole is, being that it's software as a service, once you get started with us, the next day you can basically start doing your queries. It's basically, as soon as you sign up, you get to go and gather insights. A poll of IT executives states that only about a quarter of all big data implementations are actually successful. I don't know if the folks in here have been involved in successful ones or marginally successful ones, but that's what industry statistics show. And about half of the organizations state that they have skills gaps, because big data scientists are like moon rocks. They're very expensive and very rare. And one of the things that we bring to the table is the ability to have data analysts who don't know how to program in Python or R or one of the other languages to actually gain insights and do querying of big data sets. So real quickly, this is why customers turn to Qubole. So I already mentioned how basically you get started right away. The flexibility. So we're orchestrating your clusters and running your queries inside of public clouds, and we support AWS, Google, and Azure. Okay. Yeah, I won't go into the cost and everything. We're going to go to Tobacco Road. If anybody is interested in Qubole, we're going to stay for a few minutes after the presentation. We'll give a demonstration. We'll answer any questions. We'll take you through, whatever questions you have, and then we'll also be at Tobacco Road to do a deeper dive as well. Next slide. So, as far as accessing the system and running queries, there's basically 3 ways you can initiate a query. So, one of them is if you're a developer, again, Python, R, or one of the other languages. So, how many people in the room are actually programmers in the big data space? All right, so the vast majority. And then how many people use a tool like Qlik or Tableau or Pentaho? A smaller number. And then the Analyst Workbench, that's the easy to use interface. Basically, all the queries that have been created by all users are captured. So you can basically take someone else's query, modify some of the parameters, and just rerun that. And everything else is saved, the result as well as the query. So it gives you the ability, if you just understand what other people are doing, you can actually get insights yourself. And just real quickly, so on the left, those are the 3 ways you can actually gain user access. In the center, that's our software as a service that would go into AWS, Google, or Azure. And then on the right, it's basically showing how we orchestrate everything inside of your account so that your data never leaves your account. We orchestrate the cluster, we scale it up, we scale it back down to 0, so it turns it into a utility at the compute side. And all of your persistent data is in S3 or Redshift or equivalent for the other cloud providers. So again, I don't want to sell you, so I'm going to turn it over to my colleague, and she's actually going to take you through why Hadoop, why Spark, use cases, and compare and contrast in the hybrid model between the two.
Yes, thank you, Phil, for the introduction. So before I start my technical deep dive, any of you have any question regarding the data flow, the big picture of the Qubole?
Question about all queries being available from within an organization, within the customer account. So you're working within a silo of data up in a cloud somewhere. So all the queries from within your organization that have been run against that collection of data.
So, great question. So you have.
Let me handle it. No. It's a very technical question. So sorry. Yeah. So you mean how we handle a specific query to which customer's data?
Let me take it.
It wasn't clear from his introduction that all queries are available.
Yeah. So.
Okay.
I'll take it.
Not all queries go against the same data.
Right. So what we do is we capture for all of the users that are in that same group, we capture all of their queries and the query results. So all the clusters are ephemeral. So once the queries are done, they're shut down. But the results and the query itself are still there and available. And you can view them inside of your persistent storage. And if you want to grab one of them, modify it, edit it, and then rerun it, then it'll initiate a cluster again. It'll run that query. We auto-scale up based on a predetermined SLA. Once that query is complete, we shut everything down to 0, and that's how we minimize the cost and keep everything ephemeral and keep it as a utility as opposed to a cluster that is persistent running 24/7.
Is there any evaluation or valuation of what constitutes a good query versus somebody who's just trying stuff and learning queries?
So again, very good question, but we're software as a service, so we're not evaluating the quality of your query. Now, if your query is stuck or broken, we have a solution architect team that is available through a Slack channel, and you can ask them to take a look and work with you on your query to fix it, to improve the performance of it. But we don't proactively do that unless you request that assistance.
Okay, thanks.
Yeah, regarding we keep all the history of previous rent query. It's like some of the feature in Spark Notebook. If some of you using the Spark Notebook, for all the job you submit and run in the Spark Notebook, it will persist in the notebook. So in Qubole, so we just persist all the previous rent, the query, as well as the results and the logs persist on S3, and also within the customer's S3 bucket. We don't own anything. Also, we separate the computation from the data storage. One of the things, because we provide auto scaling, when we need to add additional nodes to a cluster, maybe it's not too hard, but we want to decommission, remove some of the nodes from the cluster. It's very painful, right? Just because we need to make sure we at least keep one copy of the data in all the rest of the nodes. We don't want to remove all the data, then we just lost everything. Good? Any question? Okay, let's just move. So as I observed that most of us, maybe more than half of this group, have been working on big data related projects. Now, some of you maybe already have a lot of the Spark job in production. So may I know how many people have been working on Hive? Okay. How many people have been working on Spark? Cool, good. So at the very beginning, Hadoop was introduced to the big data world because some of the Apache community, they adopt the concept from Google, like Bigtable and the Google file system, as well as the parallel processing method of MapReduce. And the Apache Hadoop project is just a derived version of this kind of data storage, distributed data storage, MapReduce processing, as well as the distributed file system. Hadoop ecosystem provides a very rich components and services. Regarding the key services on top of the Hadoop, there are Hive, Spark, as well as HBase. Also, a lot of people, they also investigate, leveraging cascading, Storm, the search feature, Solar, as well. And as many of us know, Hadoop is ecosystem, and the whole data platform is very flexible, because you can easily integrate with the third-party tools on top of the Hadoop through the RESTful API. And also, it's very scalable, because underneath is HDFS, which is a Hadoop distributed file system. And the Hadoop data platform is very cost-effective. For example, for on-premise solution, typically user will leverage the most affordable commodity server to set up a cluster with multiple nodes. And most recently, a lot of vendor and end users, we realize moving a huge amount of data from on-premise or data center to cloud is a trend. One of the benefits we have realized is we can reduce a lot of the costs when we leverage public clouds, for example, like AWS, especially if we leverage a Spark instance, we can pay less than the on-demand instance. As well as, there's a Google Cloud, Microsoft Azure, they just follow the AWS. And what I've seen, in the near future, maybe there's a more vendor than those three top, player on the cloud space. So when we need to move the data from the traditional relational database onto the big data, the most important practice, or maybe I would say the start point, is how we build up a data pipeline. So Hive is kind of the service can help user to to create Hive table. It could be a managed table or external table. So once the table is created, it will have an entry in Hive meta store, which persists all the metadata about the Hive store, which support how the user can query the information, get the information from the Hive table. So Hive provide a SQL-like interface, which allow a lot of us, we already familiar with how to run a SQL query to move from traditional relational database onto Hive. It's very easy. And also regarding the underneath distributed store, Hive support is more scalable than the traditional relational database. Typically, it only deployed on a single server, though it could be a cluster like Oracle cluster solutions. And also regarding the Hive job, typically it will run on a huge data set. When I say most of the Hive job, it may spend about more than 10 minutes, maybe 20 minutes. Or for a very extremely large data set, or maybe the query itself is very complex. The query can be running more than 10 hours. That's what I've seen on some of the major customers like Pinterest and Oracle. So in sum, Hive provide a SQL-like interface, allow user to query, to do the data aggregation, and do the table join on top of the distributed data store. And some other of the key components within the Hadoop platform, another one is Yarn. Maybe most of you are already familiar with Yarn. Yarn was introduced on the second version of Hadoop. It separates the resource management from the data processing. And another new component is test. So test just convert the Hive and the pick job into DAG. So are you guys familiar with DAG? What DAG is? Okay, cool. So before we enable the test as a data processing engine, Hive and pick, Hive queries and pick scripts, typically it will get converted into MapReduce job. And when we're talking about enterprise data management or enterprise big data practice, we are not only care about how we handle the data injection, how we mine the data from the data set, but also we need to consider which engine we need to select, as well as we need to have the data governance practice, as well as for some of the industry like telecom, financial, data security also is very important, as well as how to set up the cluster, how to maintain the cluster, how to operate the cluster also is very important. It may cost the whole IT group to do the more than 9 to 5 o'clock daily jobs. So when I introduced Hive, I mentioned a lot of the users, they leverage Hive store as a data storage for the data ingestion. And also Hive provide a batch processing power. When we consider what kind of the data we need to calculate in a batch job, so typically in Hive, it will do different kind of the aggregation. We can get all the sum on one integer value, or maybe we just get a minimum or maximum number on a particular column. And if some of the use cases we need to have a machine learning capability, Hive doesn't support. And when we consider what is the time window for a particular Hive query, so typically we only consider the historical data till last date, or maybe till the last month, or maybe till last week. So which means regarding the event window, it's very wide. We are not focused on a single event. So when we processing some of the data related to the single events, it's more likely we are talking about how to handle streaming data. I will cover that in the later presentation. And when we need to materialize these kind of results, I would say once Hive batch job finished, we get accurate results. We can persist these kind of results and materialize in different kind of data storage. It could be into another Hive table, or maybe persist in HDFS, or other NoSQL store like HBase, Cassandra, MongoDB, as well as if you have the cloud storage, there's a more option for you, like the storage on Google Cloud, Azure, or maybe AWS S3 bucket. And regarding the results, once we get from the Hive query, it just get accurate, fixed number. Regarding the upstream data, it won't impact the previous run, the batch job results from Hive. So next, let's talk about 2 use cases, which are the typical batch processing. One thing is about how to get the score, the user score. So typically, when we want to calculate the user score, we'll do the aggregation on one or maybe multiple criteria based on one user. And regarding the time or the event window, it will be all the historical data till yesterday or maybe till last week. It's a very wide time window. And also, sometimes we also want to accumulate the total score per user to get the general score per user. And sometimes, regarding all the users' data, every day we'll have a new data set. So when the new data set arrived, usually this kind of data is in a batch. It's not like a single data point. Once the new daily data arrived, we can simplify, rerun the previous batch job to get updated results. For example, like one of our customer, Pinterest, every day they will have the yesterday data arrived. Then they just leverage the Hive and the auto table, recover partition. If some of you are familiar with the Hive, they just reload the latest data. Then they rerun the batch job to refresh the whole data set. So another example for the Hive job, I would say, is a simple segmentation. When I call it simple segmentation, I won't consider any machine learning mechanism. So we just do the data aggregation based on a group. So translating into the query, it will be select something from table, group by something, having some condition. And this also is one kind of the batching processing. And when we do the segmentation, we just need to divide the whole group of users into small subgroup based on one or multiple criteria. This kind of attributes could be like based on zip code, or maybe by gender, or maybe by age, or maybe by other interesting patterns. And also, we need to run the query against almost all the data we collect previously. And the latest event, the streaming event, it won't impact these kind of results. Yeah, regarding the segmentation, have been widely used for sales and marketing. They do the qualification and help them to do better targeted marketing and sales. So we have been talking about batch processing. That's one of the capability that Hive provide. And regarding the data set, usually it's a large amount of data. It will consider all the users, or maybe across a very wide time window. And once the batch job finished, we can get the accurate results. As well as this kind of results is fixed. It won't impact by the upstreaming real-time events. So when we're facing some of the other realities, for example, we get a lot of streaming data. So how we react quickly for some of the events, that's very important. This is beyond Hive can offer, because it cannot handle some of the streaming data. That's why we need Spark. So Spark is a very fast engine. It not only provides SQL-like interface, but also provides a streaming engine as well as machine learning and GraphX, which is geographically related features. It leverages the memory to provide RDD to speed up the data processing. And also Spark can run on a standalone mode as well as cluster mode. And you can persist the data processed by Spark to multiple NoSQL stores, such as Hive table, HBase, Cassandra, as well as S3 and HDFS. So how we can handle a streaming data pipeline? So we need some of the tool can consume all the streaming data. So typically, I will highly suggest using either Apache Kafka or maybe Amazon Kinesis. Those are all both are the messaging queue system. It is in a subscriber and publisher and a subscriber model. It can consume all the data from multiple data sources and feed them into streaming data pipeline, which offered by Spark. And the Spark streaming engine will divide the streaming data into small data batches. And later, the streaming engine will process this kind of data in mini batches. So later, I will provide some of the use cases to give you more examples. Regarding the machine learning capability Spark offers, it combined with the machine learning optimizer. It's called ML Ops, as well as the API, the MLI, and underneath is the production code. It's the machine learning library. And there's a lot of the algorithms you can play with when you do the machine learning jobs. For example, like a k-means clustering, different kind of classification, and regression. So previously, we talked about what are the typical attributes of associated to a batch job. Right now, we're just moving on the streaming job. So what kind of results we need to calculate for the streaming and the machine learning related tasks? So it's more than we just need to do the data aggregation or table join. We need machine learning. So when we talk in machine learning, we need to repeatedly to run some of the thing. We need to create a model. Then we need to adjust the model. And we need to reevaluate and adjust the previous results. So the way that Spark provides the RDD is fully leverage the information we put into the memory. And every time we run some of the machine learning tasks, we get the results. We go back to adjust the data and create another set of the RDD feed for the next task in the Spark job. And when we handle this kind of the calculation, typically it will be in a very narrow event window. For example, we consider a transaction or maybe some of the streaming data. It just within maybe within a second or maybe a few seconds. So before that event occur, we need to prepare something. For example, doing the segmentation classification, trying to find some of the previous pattern. When this kind of events occur, we need to quickly identify if these events match for the previous pattern, or if this kind of events fall into some of the clusters. Then we need to set an alert or maybe set up a trigger, which will let the user or maybe let some of the vendor to take actions to prevent something or maybe to detect something in near real time. And regarding the previous calculated results generated by the Spark job, it will be impacted by the upstreaming data. So which means every time when we get results from the streaming calculation, we just get approximate results. Maybe it's not 100% accurate. It's like some of the information we Googled, or maybe we leverage some of the real-time traffic application. We get the near 100% accurate information. But that's good enough, just because we don't need to have the 100% accurate information. We just get a sense how bad the traffic is on a particular highway, like at Highway 85 at this moment. Okay, so in financial world, one of the painful things is how we can quickly identify fraud. It's not only protect the consumer, but also it protects the financial institution and firms. So this kind of the transaction is a streaming data. If we want to approve a transaction, so typically it's just within a few seconds. So before this kind of event occurs, we need to run the machine learning jobs, trying to find what are the interest pattern, what kind of pattern could be a fraud, or which one is not related. And also we need to do the classification, k-means clustering, and do some of the segmentation. For example, what kind of transaction have the high possibility it could be a fraud, or maybe in which area, in which shops, they have a high ratio. And also we need to generate pattern recognition before these kind of events arrive. So when the events arrive, we need to quickly do the pattern recognition to figure out if we need to send out an alert. Some of the real example, I have a cousin. His name is Phil. He is a very healthy person, and he's in later 20s. And in the past 5 years, he never visited a doctor. He never have any prescription, medicine. He never visited a pharmacy. But somehow today, he visited a doctor and got a prescription. So he went to the pharmacy. He's trying to buy some of the medicine with total cost above 500. He just used a credit card he used every day. But somehow the credit card transaction got denied. Why? Just because the back end, the credit card system, it just say, Phil is a very young and a very healthy person. He never had any health-related problem in the past 5 years. So suddenly he want to buy medicine more than 500. Potentially, it's a fraud. So they just put this credit card transaction on hold. They asked the cashier, so you have to ask the user to make a call to the credit card to authorize this kind of things. So this is one of the example of the fraud detection. And also, you want to detect these kind of things immediately when they submit this kind of transaction. So another machine learning related use case is about trend analysis or trend prediction. So trend analysis was introduced by the telecom company. It is related to identify a user may want to switch from one vendor to another vendor. So how we find which group of users who will have the high probability to switch vendor or maybe cancel a certain of services. So we need to do scoring, user scores. Also, we need to do the segmentation. And usually, the machine learning task also we need to put the weight to calculate the overall score. how likely the user may want to switch from one vendor to another one. And also, right now, not only the telecom company, they have been doing this kind of the trend prediction. It has been widely adopted by the other sector, like financial services, for example, like a loan program, as well as the retailer and the social media. So another of the things, everybody have been talking about Internet things. So I believe all of us, we have a cell phone, we use browser to do a lot of the searching, and also a lot of us, we have some fancy vehicle. Maybe it's just a standard vehicle. No, within the vehicle, there are multiple sensors. One of the sensors just help the satellite to uniquely identify, okay, you are this vehicle, and where you are located. And also, there's a lot of devices. For example, some of the appliances at your home, as well as the medical facility. So within these kind of devices, they also have a lot of sensors. So for one sensor, there are multiple data points. Usually, we call that endpoint data. So we can collect tons of the data from different kind of devices, or maybe from your cell phone, from your laptop, from your vehicles. No, not yet. We'll go back. Yeah. So regarding this kind of the streaming data, one of the challenges is how we collect this kind of data in near real time, and how we do the data, how we do the data drawing and do the machine learning on multiple data sets. So which means, we are not only need to have the streaming data practice, but also we need a machine learning and the geographically related practice. And some of the interesting topic about, smart city, smart home, and as well as the intelligent the transportation. For example, I just called the real-time traffic. How we provide the real-time traffic information, there's a multiple way, and also we need to union all the information together to put everything on a single big picture. So one of the things, given one of the sensors from your vehicle, we can calculate the density on a specific area. For example, like a Highway 85 from exit 1 to exit 2, how many vehicles at one time step. Then when the time passes, we recalculate the density. And also, we just see what's the difference between the previous time and the current time steps. So we can see what's the trend of the traffic condition on that particular area on Highway 85. And also, we need to join the other data, or maybe not join, maybe just like union the other data to apply the additional information. If there's a road construction on that particular of the highway, or if there's an accident, if some of the highway patrol, they want to do something to block some of the traffic, just for some of the, maybe there's a truck want to clean or maybe remove a big chunk of the thing from the highway. So we have been talking about how to handle the streaming data. So typically the streaming data is just like occurred in a very small time window, and it should be focused on one single event other than all the historical information, all the historical data. And when we, in our real world, I would say there's tons of information we can collect from different kind of devices, or maybe from the machine's log, like server's log, from computer, the community server, as well as social media information. And sometimes also we need to leverage the traditional relational database, the structured information, or maybe some of the information from like a ERP, CRM, kind of the business applications. So we need to leverage the Kafka, the messaging queue system, to gather all the information and feed them into 2 layers. So regarding this data flow, the architecture, usually people just call it Lambda architecture. We'll have the batching layer and the streaming layer. So later, we'll gather results from those 2 layers and feed it into serving layer. So on the survey layer side, usually we just leverage the data visualization tool like Tableau, Click.
What are the sources, the 5 blocks on the left? What are the captions read for that?
Devices.
Devices, logs, social media, RDBMS, others.
Okay.
So which means now it could be like a structured data, unstructured, or maybe semi-structured data from devices, sensors, or click streams, or maybe the existing applications. So for the benching processing, I would say Hadoop Hive is one of the options. We are highly suggest for that because once you create a Hive store, especially on the Kubel platform, we provide a unified meta store. So which means once you create a Hive store, you can use the Hive query or maybe Presto engine, as well as the Spark engine to run the query on top of the same data set. At the same time, Spark just enable the streaming data processing. So which means we can parallelly to calculate the information in bench mode to get the 100% accurate results, as well as the near accurate results from streaming pipeline. So regarding this kind of information, we can persist into various data store. It could be like a HDFS in a Hadoop traditional way. Also, for some of the fast data ingestion, I would highly recommend like Cassandra HBase, as well as MongoDB. It's good support for the multiple hierarchy of the information. And also, you can leverage S3 bucket, just another file system, or maybe object store. Regarding some of the highly accurate information, if the data size is not very large, it's less than gigabytes, or maybe it's less than terabytes, we still can consider use the traditional relational database like Terra, MySQL, or maybe Redshift, just because it's very fast when you leverage the data visualization tool to show the data in a fancy way. So which means, about the hybrid solution, I would say it's more like we marry the traditional enterprise data management with the latest big data management. And another thing, I recently learned from the Google conference is because some of the Spark engine and product haven't been fully matured, as mature as the Hive. So which means in the near future, when we can provide more reliable streaming engine, possibly we can dump the batch processing. We just need to handle everything in streaming mode. So I believe so we can make a contribution to the streaming engine. Maybe it could be Spark or maybe something else. You can establish your baby company. Do you have that?
So we have about 10 minutes left. Should we start the Q&A now?
And do you prefer like a Q&A or maybe just go through another use case recommender?
I think we probably have time for another use case.
Okay, sure. So who are the online shopper? Do the online shopping? How many of you? Okay, cool. Yeah. Also, I'm one of them. So also, I just play some of the trick with this kind of this kind of vendor. So have you been realized if you put something into your shopping cart, but you didn't make the transaction, what may occur in the next couple of days?
You put something in your shopping cart and then you can put it back.
Yeah, so if you put something in your shopping cart, but you didn't check out, what may occur in the next couple of days?
Send you an email.
Yeah. So this is part of the recommender or something related. And how many of you like watch movie? How many of you have like a Netflix account? Yeah. So Netflix, they provide the hybrid recommender engine combined with the the collaborative filtering and the content-based filtering.
Could you make it quick recommending the thing that I bought 2 days ago? I mean, that's
Yeah, that's related to collaborative filtering. So that's an assumption. So sorry, let me answer that question first. So which means, if you like something, you purchase something, the engine will assume you will like the similar or maybe same product in the near future.
like tires, because I buy tires every day.
Yeah, so you buy tie, right? So one thing is, if you buy tie, so it will have say, okay, you need a dress suit, or maybe you need a suit, a dress suit.
What alignment is in order?
That would be better than asking if I want to buy more tires.
Yeah, and also it will get trying to spot if a returned customer. Usually they will persist all the your historical data, and also they will create a certain pattern on your profile, and also given your credit card information, they get your home address, and also very easy to get information about your age, your family income, etc.
There's no logic built in about tires.
It's the fallback recommendation.
But it really depends. No, for some of the salesperson, they may change a tie on daily basis, right? So which means they need more than one tie.
Maybe you just bought one tire and now you need 3 more.
If you just buy tires, you probably adjustable.
You never tied about more tires.
It's like you have more vehicles, so
That's right. You're too
tires
common.
and other vehicles.
So, you have the term hybrid
Hybrid.
on the slide. So I was wondering, what is it a hybrid of? Of what is it a hybrid?
That's a very tough question for me.
So just repeating the question.
Yeah, sure. So the hybrid is more like we'll have a multiple approach to implement the recommender. You are talking about the recommender, right? So it will combine at least the collaborative filtering and the content-based approach.
So, a hybrid of the bullet points above.
Yeah, above. And because regarding the recommender engine, sometimes we only focus on one user. For example, what's your name, please?
Mark.
Mark, yeah. They only get all the historic data of Mark. They were trying to see, what's the Mark's to purchase item. They will give the recommender only based on all the historical transaction in your account. But also, we will consider for other users who have a similar profile of you, maybe almost the same tier of the family income, maybe the gender is very easy, right? Or maybe the age, or maybe the style, right? They will gather, okay, another group of person, they shop the same thing as you did before. They also shop another kind of the products and services. So when you trying to submit a transaction, make a purchase, usually on the browser page, either on the bottom or maybe on one side, you will see, you may interest in this ABC. And also some of the marketing team, they also will play some trick. For example, that's a real case. Brooker Brothers is sort of the middle class or maybe New York's like the store. They provide like a formal like suits, as well as a lot of accessory. Yeah, Brooks Brothers, as well as the women accessory like the handbag. So one of the MBA study is Brooks Brothers. They have one particular handbag. It's very expensive. Usually, most of their handbag is the retail price for one handbag about 400 to 600. But somehow, in one of the flagship store, they have one handbag. The retail price is 2,000. And it's harder to see this particular bag is much better than the rest of the like a 400, 6,000 handbag. So this is kind of the trick. They want to give the consumer impression. This one is very expensive. The rest of things is very cheap. It's more affordable. And also on the website, on the recommender, sometimes they will give some of the information. Okay, you would like to shop, more expensive things. For example, one pen, one of the car key, about 55 per pen. But we have a lot of promotion on $20 per pen. And we have tons of them in our storage, which we want to sell them soon. So they may just say, okay, almost same product, very similar product. One pen, we have a very low inventory, we higher price. But we have a lot of things, another kind of pen in our the back store, we just lower the price because we want to promote another set of data. So regarding the recommender engine, behind the thing, they also have a lot of things. And also, it's more like a kind of battle. We fight with this kind of retailer. How to be more smart, how to save money to buy a good quality stuff with a more affordable price. And if you know how they do the machine learning, how they do the promotion.
We have like 2 minutes, and
Sure.
we have other questions. Yeah.
So in streaming mode, how do you foresee getting in more streams of data? I mean, from various other streams. Like, for instance, if you want, like in Hadoop, you would have, it's all batch processing. You get the data in a file and so on and so forth. But in the case of streaming mode, how do you foresee getting in the data from multiple sources?
Okay, so regarding the streaming data processing, one of the challenges, we want to capture this kind of information in real time. And also we need to calculate immediately when data arrive. And also we need to adjust the previous results. We not only want to calculate the data, get the results, but also we maybe need to adjust the previous results. And typically, all the information, we put them into the memory. It's not persisted into a storage file system before we process it.
So it's all in memory itself?
Yes, because when you in computer computer world, we know the information we get register is the most fast way. The second one is from the memory. The third way, if it is a cluster, is from the context-based RPC. The most lowest, most inefficient way is retrieve data from disks.
So Spark is running like a...
Yeah, if the data can fit into memory, we'll fully leverage memory. Yeah, that's the philosophy of Spark.
But you could, how would you use it for a recommender system, for instance?
For a recommender system, it's very, how would I say, it's not easy to say recommender system. It will combine a lot of the batch job to get all the information based on all the previous, the history, to get a pattern. And also it's involved a lot of machine learning. You need to do the classification, segmentation, and also you need to run a lot of regression. And also And also regarding recommender, also it may consider more data than something we already discussed. The weather information maybe will have the impact. Weather, the economic, the market also will impact.
Did that actually answer your question?
I know there's a lot more to it now.
One of the way I would approach that too, though, is so you have your batch data, which is everything you know about them, their demographics, their name, what they purchased from you in the past, and then you ingest all of their social media. So So what are they liking? What are they pinning? What are they saying? Where are they going next? So that you can have your recommender or predictor say, send a 10% coupon off of this because based on what they've done in the past, based on what we know about them, this is what we expect them to do in the future.
Yeah.
And that's a part of the queue. That's done by the queue.
That's the hybrid model of taking your structured plus your unstructured data, your batch plus your streaming data, ingesting, joining, and then making a recommendation.
Yeah.
The EU has something of a different view about privacy. Have you?
Yeah, that's very, yeah, I would say, yes, definitely some of we really have concern about privacy. So that's why some people, they don't want to buy some of the device or maybe vehicle with sensor installed.
So again, I would answer just a little bit differently. There's the technical answer, and then there's the answer of, so we operate inside of a cloud, and we operate in various zones of various cloud providers. So if you wanted to have EU laws governing your data and governing your processing of that data, then you would utilize basically QBOL out of that particular zone. And if you had it on-prem, you do the same thing. So you basically just take your data processing and your data and you move it to the area, region, or zone that you have favorable legislation or legislation that you want against your data.
Yeah, and also we can set up a different kind of security, like a VPC security group.
John, do you have a question?
Sure. So what do you tell customers about particularly you're operating a multi-tenant system as your infrastructure, and you may have, or you're using third party like AWS, what do you tell customers who are looking for capability?
All right, so did you ask about performance as well as security? Or
This is more about performance, predictability of jobs, and that the customer runs. So if I'm using your software as a service, and I have a particular job I want to run, but Netflix comes in and wants 1,000 nodes, and my job runs 3 times as long, how do you provide some QoS around the performance of a given job for a customer?
all right, so that's a great question. I'll start it, and then if you want to add, because I'm sure I'm being
Sure.
complete. So again, we're orchestrating inside of your account. So the only way that our performance would not meet your criteria for your particular query is if AWS or Google or Azure didn't have enough firepower available for all of its customers. So the noisy neighbor syndrome really shouldn't impact you because we're orchestrating inside of your account and we auto scale up. So there's a predetermined SLA and you can influence that if you like, but we set it initially. And every 30 seconds we evaluate the performance of each individual query. And if we feel that there are more tasks than the number of nodes to accomplish those tasks in the expected time or the SLA time, then we would add additional nodes into that cluster. And from what we've seen from our customer experience, we have over 100 customers and we're processing over 300 petabytes of data per month. We don't have a situation where any one individual customer doesn't have enough nodes available to them to complete their queries. So we haven't had that as an issue yet. Does that answer the question, or did you have a follow-on?
Yeah, that's
Among the population of your customers, have you found a relationship between their election of using Spark versus Hadoop correlated with the nature of their business?
So the question is, based on our customer experience and what our customers are doing, are we seeing a prevalence of Hadoop versus Spark? And I'll start it, but I want you to jump in on this one. So most of our customers, when they get started, and the vast majority today, are basically Hive-oriented and Hadoop-oriented. But over time, we're seeing that the customers are seeing different things out there, things available, and they're realizing that their use cases, their workloads are better served by Spark. So we're seeing a migration in that direction. But if you basically took a snapshot today, the majority of the jobs, the majority of our customers are still focused on Hadoop. We see the growth on Spark is much greater, but the actual percentage of jobs on Hadoop is still larger.
Yeah. Yeah, so what we have seen, the majority of job on in big data platform, more than 2/3, more than 66, they are still Hive MapReduce job. But regarding the trend is more users, they want to move on to Spark. It's not only it is fast, but also it have enabled the machine learning capabilities.
And we also have some customers that are coming on now that are doing machine learning, and they're still in the process of writing the algorithms. So until that's completed, they're not running their Spark jobs, but once that's done, then the percentage is going to start to shift. So as more and more complete the algorithms, we'll see a higher percentage of that. And again, that trend is growing faster than the traditional side or the Hadoop side.
Are they, I have a follow-up.
Okay.
Are they in communication with you about the nature of their business and what they expect to accomplish? And are asking you about, is this a good idea? Should we implement this? Could we implement this with Hadoop, or do we have to launch into Spark? Do they figure that out themselves?
So the question is, when a new customer comes to the table, are they asking us for a suggestion or guidance with respect to, what's the best engine to accomplish that? So it depends on how and where the customer's coming to us. We have a partner network, system integrators, and other professional services type of organizations. And a lot of times they do that consulting before they even come into us. So that recommendation has already been analyzed and given to them. We also have a solution architect team. We've got several more Kalins back in Mountain View. And when we actually have that first prospect conversation, we start out with, what is your use case? What is your current data environment? Are you doing ad hoc versus scheduled queries and on? So after we ask all those questions and they give us feedback, then we tailor the actual demonstration, and then we basically have a 2-week proof of concept with the customer where we basically handhold them for a couple of weeks, make sure that what they want to accomplish can be accomplished inside of our software, and then after that 2-week period of time, they decide if they want to proceed with us.
Yeah.
And then after that, we also provide additional support. So the answer is yes, we hold their hand and we do give them assistance and guidance, but a lot of times they come to the table with more data scientists and more knowledge than us.
Yeah, and some of the information I can share with you at this moment, I just say at this moment. If you don't need to have a real-time calculated information, you can afford to wait for a couple of minutes or maybe a couple of hours. Hive is more production ready. It's more reliable than Spark. But Spark, and I will say, maybe they can catch up quickly. Yeah.
Yeah, there's a lot more resources working on Spark and next-gen engine.
Yeah, but if you have implemented some of the model to do the data, do the regression, classification, this kind of things, leverage the machine learning library, then you have to choose Spark.
So you said you spin up clusters on demand. What versions of Spark do you offer?
Okay, yeah. So regarding the auto scaling feature that Cube offers, we allowed user to set up 2 parameters. When there's the minimal computing node, when I will go to the on demand and the spot. So regarding we add additional nodes, we can choose either on demand or Spark instance. On demand EC2 instance with a fixed rate. For example, like one of the tier, you just pay like $1 per hour. But regarding the Spark instance, the price is fluctuate. Depends on the supply, the demand on the market. Most of the time, the rate of the Spark instance, you pay much lower rate.
What versions of Spark?
So he wants to know the version
Spark.
of Spark.
Oh, sorry. Okay. Yeah, we support multiple versions from the earlier version 1.3 to 1.4.1, 1.5.0, 1.5.1, and to latest 1.6.
So from a pick list, you get to choose, because you might have some of your workflow built on a previous engine. So we give you the availability of all of them, and you pick and choose. And if we don't have the engine version that you would like or that you require, you can also bootstrap. so you can edit anything you like and basically have those tools at your disposal as well. And thank you all for your time and attention tonight. Hope to see you at the back of the road.
Thank you very much. Yeah, we're all set. Yeah, I'll turn it off. I think it just needs to be held down. There we go.